All right, so we're on page, what is it? 366, number 51? 357? 367, number 51. All right, so 367, number 51. Here we go. We got a nice little triangle drawn. 32, 57. Y, and it says solve for the variable shown. Now, in a couple of problems that we did earlier, we found a side using the Pythagorean theorem. That's not going to work this time, right? Because we don't have enough information to do that. So we're going to rely on our trigonometry. We're going to use trigonometry to find the missing side. You're going to hear me in the next few months say over and over and over again, if you need to find the side of a triangle, you have three options. Okay, so here's my tool kit. There's 3 tools in it that will find the side of a triangle. Sohcahtoa, law of sines, law of cosines. Now, we don't even know what those other things are yet, but we know Sohcahtoa. And since this is a right triangle, we can use it. If we're looking at the angle of 57, which side is this? Opposite. Which side is this? Those are the 2 sides that are part of this problem. The hypotenuse isn't, I mean, it's there, but it's not part of the problem. It's not identified or labeled in any way. So I need to do the problem in terms of opposite and adjacent, which means I'll use which of my trig functions? Tangent. So the tangent of 57 will equal 32 over y. Does that make sense to you? The tangent of that angle is going to be the opposite side over the adjacent side. Now I'm going to solve that equation. This is a calculator problem. I'm going to solve it. I'm going to multiply by y. And then what? I'm trying to get y by itself, so I'll divide by, and so I'm going to go to my calculator. Now I do have one request of you. Before you type it in, would you go to mode and make sure that degrees is highlighted? Because 57 is a degree measure, and your calculator needs to know it's a degree measure. So make sure degrees, go to mode, make sure degrees is highlighted, and then just type in 32 divided by tan 57. And did you get 20.78? That's it. That's all there is to it. Let's do the next one. That was 51. Let's do 52. Same thing, 52. Now, do you think we'll use tangent this time?
No, you use sine.
We're going to use sine. And we're going to use sine because with regard to this angle, this is the opposite, and this is the hypotenuse. So sine 43 equals x over 14, opposite over hypotenuse. So x is 14 sine 43. Everybody still with me? So 14 sine 43, and I got 9.55. What about you?
You got 9.5.
I did. What did you get? Go with. That's good. Probably never in your life are you going to be walking down the street and have a triangle drop out of the sky and say, solve me. That's not how it works. Take a look at problem 62. This is where we use trigonometry in real life. Kirsten's out surveying. She measures an 8-degree angle of elevation above the horizontal to the top of the tree that is 120 feet away. How tall is the tree? So here's our scenario. This is 8 degrees. That's called the angle of elevation. If Kirsten is looking ahead and she looks up, that's her angle of elevation. And she knows she's standing 120 feet away from the tree. How tall is the tree? Okay, you got a thought on that?
So would it be tangent?
Definitely tangent, because if you're using 8 degrees, this is the opposite and this is the adjacent. So that's a tangent. So the tangent of 8 is x over 120. So x is going to be 120 tan 8. I got 16.86. Is that the answer to the problem? What do I need to do? I need the height of the whole tree, so I need to add 5. This is the whole tree, right? I have found this part of it to be 16, so the answer is 21.86 feet. Does that make sense to everybody? All right, you are amazing. Now we're moving on to the next step. Would you take a look on page 381? We have another new vocabulary word. What is the one vocabulary word I've already given you today? Quadrantal. And what are quadrantal angles? Angles that end on an axis, right? And examples were 90 and 180, et cetera, right? Well, now we have a new vocabulary word, coterminal. Coterminal angles. I'll give you an example, and you see if you, I'll give you a couple examples, and you see if you can come up with the definition or the meaning of coterminal. Some angles that are coterminal would be 60 degrees, negative 300 degrees, 420 degrees. Those are 3 angles coterminal with each other. These angles are all coterminal with each other. Think about what those 3 angles look like, and what do you think the word coterminal means? Clara?
When added together, they equal the quadrantal.
Oh, well, that's an interesting concept. I don't know if that's always the case. Well, no, because if I add these 2 together, I get 120, and 120 is not quadrantal. Do me a favor and draw these 3 angles. Just draw on the same thing, if you don't mind, on the same grid. Draw those 3 angles in standard position. So you got 60. What's negative 300 look like? Oh, they all land in the same spot. Co-terminal. They share a terminal side. They stop in the same spot, as Jack said. If you draw a negative 300, doesn't it land in the same spot as 60? And what happens when you draw 420? Now, 420 is too big. So you go around 1 time, and then how much extra? 60. All of those angles have the same terminal side. In other words, when you draw them, they all end up there. Are those 3 the only angles that would end up in that spot? No? Give me another one. 780. Now wait a minute, 780, that is huge. What does 780 do? 780 goes around not once, but twice, and then 60 more. All right, now let's talk about this for a second. 60 is kind of the base angle that I started with. How did I get from 60 to negative 300? As I was putting this problem on the board, what was my brain doing? Minus 360. So to get from here to here, I subtracted 360. Now how did I get from here to here? I added 360. And then how did we get from here to here? We added 2 360s. In other words, in order to get coterminal angles, you either add a revolution or you subtract a revolution. You add 360 or you subtract 360. And if you want more, you add 2 360s or subtract 2 360s or 3 360s or however many you want. So how do you find coterminal angles? You add or subtract revolutions. Now, notice I didn't say you add or subtract 360, because if the original angle is in radians, you won't want to be adding 360. What would you add if you were in radians? 2 pi. You'd add or subtract 2 pi, because 2 pi is a revolution. So if you are in degrees, okay, let's do one. Let's say I want an angle coterminal with 10 degrees. Give me any angle coterminal with 10 degrees. I heard 370. Any other possibilities? Negative 350. Those are probably the two that are going to be first in your mind, because you added a revolution and you have subtracted a revolution. But what if I say pi over 5 radians? Okay, now wait a minute. What are you adding? 2 pi, which is 10/5, right? So one coterminal angle would be 11 pi over 5, and the other one would be negative 9 pi over 5.
Yeah.
What are coterminal angles? Angles that stop in the same spot. They share the same terminal side. They end up in the same place. That's what coterminal angles are. How do you find coterminal angles? Because you know sure shooting that's going to be a test question. How do you find coterminal angles? You add or subtract revolutions. If you are in degrees, you add or subtract 360s. If you're in radians, you add or subtract 2 pi. Okay? Alright, that's easy. Alright, I want to take a look at on page 381 now. I'm on page 381. I want to look at problem 43 because it looks incredibly complicated. Problem 43 on page 381. By the way, this is section 4.3, so by the time you're done with me today, everything that's exam material will have it covered, okay? We still obviously lots to learn, but exam material. All right, so here we go. It says find the sine and the tangent if the cosine is 2/3 and the cotangent is greater than 0. I'm finding the sine and the tangent. Now, this is where you really have to start putting the pieces together. If I said to you the cotangent is 2/3, would you visualize a triangle where the adjacent side was 2 and the hypotenuse was 3? Is that what you would visualize? I hope so. That's what you should visualize. The part that you're missing, though, is it doesn't always have to be in just quadrant 1. Can you think of another quadrant where my cosine, adjacent over hypotenuse, would be a positive 2/3. Can you think of another quadrant where that would happen? Somebody said 3? All right, let's look at 3 real quick. It's not 3. Let's look at 3 and talk about why it's not.
2 would be negative.
In quadrant 3, here's my angle. Could I have this be 2 and this be 3? No. See that 2 right there? He would have to be negative if I were in quadrant 3, right? Oh, quadrant 4. Who said it? Someone said quadrant 4. Very good, Rachel. Quadrant 4 is where I'll be positive. I'll add it on up here. Because in quadrant 4, x is positive. And what's cosine? X over r. If you want cosine to be positive, then x has to be positive. Right? Now somebody might be thinking, well, what about r, Mrs. Ford? R is always positive. I hope I said that the other day or today or sometime. If I didn't, I'll say it again. R is always positive. R is a non-factor. It's always positive. X can be positive or negative. If my cosine is a positive number, then all that's required is x has to be positive, and that can happen here or here. Would you agree? Now that could be problematic because in the top triangle, this is positive √5. Here, it will be negative √5. All right, I need to know which one it is. Could be either one. What does this tell me? What's greater than 0 mean? Positive. It means cotangent is positive. All right, so what's cotangent by definition? The reciprocal of tangent. Tangent is y over x, so cotangent is x over y. If you want cotangent to be positive, kids, where does that happen? Could cotangent be positive in quadrant 1? Could cotangent be positive in quadrant 4? No. So therefore, which of these two triangles do I want? The one on the top. Because that's the only triangle that has a positive cosine and a positive cotangent. Now I'm ready to answer the question. Well, that's easy. What's the sign? I'm in the front of that top triangle. The sign is √5 over 3. And the tangent is √5 over 2.
Could it be positive in the quadrant 3?
Cotangent can be positive in quadrant 3, absolutely. So this guy was positive in 1 and 4. This guy is positive in 1 and 3. The only overlap is quadrant 1. Now, for those of you in La La Land, how does he know the cotangent is positive in quadrant 3? It's x over y. Tell me about x and y in quadrant 3. They're both negative. And what happens when you put one over the other one? If they're both negative, it comes out positive. Yep, very good, Burkhart. Good thought. Let's try another one of those because they can be a little confusing. Let's do 47. We know the cotangent is a negative number. Now, kids, you're going to draw 2 triangles. Okay, there's 4 quadrants. Every function is positive in 2 of them and negative in 2 of them. So we're going to draw the quadrant, or draw the triangle, where the cotangent is a negative 4/3. Where are we going to draw these if the cotangent is a negative number? It goes through all the stuff's floating around in your brain.
1, 2, 2.
Quadrant 2 is one of them.
Or 3.
Or 2 and 4. That's where your cotangent is negative. Now stop and think. Cotangent is x over y. If you want that to be a negative fraction, then doesn't that mean one of these has to be negative? Not both of them, one of them has to be negative. That happens here or here. Now the other stipulation, okay, so you narrowed it down to 2. The other stipulation says the cosine has to be negative. So this has narrowed us down to these 2 quadrants. Which one of these 2 quadrants has a negative cosine? Two. Yes. Why 2? Cosine is x. Which of those 2 quadrants has a negative x? Just 2, right? So this is not the right quadrant. This is the right quadrant. The cotangent is negative 4/3. I'm going to do my Pythagorean theorem. What's that third side? And I'm finding secant and cosecant. Third side's 5. That's Pythagorean triple. You should probably all have that one memorized. All right, so I'm ready to fill in. The question was, what's the secant and the cosecant? So what's the secant? Secant. Let's see. Secant is reciprocal of cosine. So cosine is negative 4 over 5. So secant would be 5 over negative 4. Cosine would be 3/5, so cosecant is 5/3. Anything? Would you write what now? Okay, make sure, if you're typing in that negative sign, I wouldn't because you're squaring it out. But if you're not putting negative 4 in parentheses, it won't do the right thing. So if you're going to type it in, which with numbers this size, seriously, we shouldn't be typing this in. But if we are, make sure that's in parentheses or it won't work right. I would never type the negative anyway because it's always going to disappear because if you're doing the Pythagorean theorem, you're squaring it. All right, let's see if we can pull a couple more off in here. Michael's watching the clock. He cannot wait to get out. Problem 18. I'm talking about Michael Cohen. Number 18. Number 18, all it says, do not type it in on your calculator. It says, problem 18 says, determine if the tangent of 192 is positive or negative. Do not type it in. This is number 18. We're determining if the tangent of we are on page 381, number 18, says determine if the tangent of 182 is positive or negative. Where is 182?
It's 192.
It's 192. Where is 192? That won't impact the answer, believe it or not, but it is 192. It's in quadrant 3. So you have an angle in quadrant 3. And the question is not what is the tangent, but is the tangent a positive number or a negative number? What's your thought?
Negative.
Gotta be positive. We get to negative.
Exactly, Dylan. You haven't had your eyes open most of the period, but you opened them up just in time. This is in the third quadrant. Won't x and y both be negative.
Yeah.
Tangent is y over x. If you are in the third quadrant, they're both negative. So when you put them on top of each other, the tangent will be positive. Positive. All right, one more. Number 6. Number 6. Last one. I will shut up at this point after we finish this. All right, so here we go. Number 6. I'm going to draw the picture they drew. They got an angle in standard position. Looks like this. Contains the point 3, -5. And this is theta. And I'm supposed to be finding the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. We've done a couple of these earlier and they were pretty easy. What do you think I need to do to get started? I need to get my triangle drawn, absolutely. So here comes my perpendicular. Now, they gave me the coordinates of this point for a reason. They tell me the sides of the triangle, or a couple of them anyway. If that's the point 3, -5, then this is 3, and this is -5. Agreed? Now what am I going to do? Pythagorean theorem. Oh, I know I said you should know the 3, 4, 5, but please don't say 4. This is the hypotenuse. It can't be 4. Got it? It can't be 4. Right. So we're going to do our Pythagorean theorems. We have 9 and 25. So root 34. All right. Take a minute, fill them in. We'll check them. And then you can go. How'd I do? You think I'm okay? We match? Everybody got negatives where they're supposed to be? Alright, as long as you have no questions, you are free to go. Please tell me I see you again tomorrow. Oh, that's right, I don't because it's math.
Oh, yeah, what about
Okay, so I have to watch the video. I do have alpha tomorrow. Would I have had you tomorrow if it wasn't math?
Yes.
No? There is some chemical smell somewhere. Anybody smell it? What is it?